Alright guys, today we're going over 1.3. You should have this in your OneNote, but it'll also be on Canvas. And we are talking about segment bisectors, the midpoint formula, and the distance formula. So today is all about really using formula. It's a lot of algebra, but it's using formulas to find missing things on segments, so missing points and lengths. A couple definitions that I really want to go over with you is, and just terminology. When you see something like this, where you've got a segment off to the side here, remember that my endpoints are point A and point B here, and we usually write that in the form of an XY coordinate, right? So X tells you left or right from the origin, 0, 0, and Y tells you up or down from the point 0, 0. Now, just for making sure that we know which point we're talking about, we use this little subscript underneath the letters X and Y, and the subscript, it's like the opposite of a superscript, which is, exponent. So it's like, this is just saying, okay, oops, this is just saying, okay, well, we're talking about X for the first point and Y for the first point. Now, it really doesn't matter if you make A your first point or B your first point, as long as you're consistent with it and your numbers stay the same, okay? We're going to use, for our purposes today, M is going to be representing the midpoint, and we're going to define that here in a second. We call these guys here tick marks, and so this here and here is called a tick mark. Now, a tick mark could be 2 lines, it could be 3 lines like that, but all that's saying is that this part of, let's pick purple, this part of my segment is congruent to this part of my segment, okay? And remember, congruency just means that they're the same shape, same length, same distance, however you want to think about it. So a midpoint is that point directly in between A and B. When you think of the prefix mid, that's really what it's telling us. It's in the middle. And when we're referring to something in the middle, we have to be precise. It's not just kind of, somewhere over here. It's like the exact shortest distance between A and B. And so we are going to do a lot today with these two endpoints and even the midpoint. And so, like, for example, if I wanted to write a coordinates for a midpoint, I could say, well, this is my, third point. So it's my third X that I've got, and this is my third Y that I've got. And we don't see that in the actual formula anymore, but you could. That subscript just means, okay, those numbers go together when I'm talking about a number, the 0.23 or something like that. Well, that's saying that the 2 and the 3 both go with that same midpoint for M. Okay, so just remember, again, that's our congruent symbol, and it's saying that these tick marks are saying, okay, well, anything with the same tick marks. So let's, for example, if I've got another segment here and the midpoint's here, I might have 2 tick marks, but since this piece and this piece have the same tick marks, they mean that they're congruent to each other, or they're equal. They could be 3. It just depends. So you want to make sure that if you've already used one little dash, tick mark, whatever you want to call it, to represent these two segments, you can't reuse them unless you're saying another segment is also congruent to those two. Okay, you could say that. So, you've got a hard time zooming. There we go. We've got segment bisector we're going to talk about first, and then we'll come back. I'm going to kind of go back and forth from here. Midpoint formula and then distance. And so segment bisector, this used to be a foldable, which is why it kind of looks like this, but a segment bisector, and at any point, again, if you need to pause this, please feel free. I'm going to run through here so the video isn't itself too long, but yeah, I just want to make sure that pause it if you need to. So segment bisector is a point, a ray, a line segment, or plane that intersects the segment at its midpoint. So in this case, the segment bisector, think about where you've heard the prefix bi before. Usually you're thinking about two things, right? If you're dissecting something, you're cutting it up, right, into multiple pieces. But if you're bisecting something, you're cutting it into two exact pieces, okay, two exact length pieces. So what a segment bisector itself is that thing that cuts it, right? So in this case, in our picture here, it's actually a line. It's this line that's the segment bisector. It is the segment, so this segment here is actually being bisected. I shouldn't have highlighted that yellow. Let's undo that yellow here, because I want to make, let's say, this purple. I'm going to make this yellow, because that's actually the bisector. This segment is being bisected. So think of it like where you hear, you go to science class and you're dissecting a frog. You're the dissector. You're the one cutting it in half. The frog is being dissected. And again, these tick marks here are just saying, well, this piece and this piece of the segment are congruent. They're equal lengths. You don't have this up top, what you're actually supposed to do, but you're supposed to solve for x and each length of the segments AB, BC, and AC. And remember, when we're talking about lengths of segments, we don't use those segment bars on top. And I talked to you guys in class about why, like in big ideas or the Canvas quizzes, might look a little different. Remember, if you're talking about something and I can't write that, the problem with the big idea or the Canvas assignment was that we couldn't actually put a bar on top. However, in this case, we wouldn't want to, because we're talking about the lengths, and so you guys learned that either last section or the section before. So I think it was the first section. And so here we've got, I'm looking at this and I'm saying, all right, well, it's, oh my gosh, come on. It is, just looking at this picture, I've got segment AB and segment BC. They both have tick marks on them, so that's saying, okay, well, they're equal length pieces. Right now, x plus 9 represents the length of AB, and 4x represents BC. Well, algebraically, that means that we can set up an algebra problem and solve. And that's exactly what we're going to do. So I know for step 1 here, I can set up geometrically here. I've got this length of AB, that's what this means, equals the length of BC. That's what this means. Okay, and again, I'm writing kind of the reason why off to the side. You don't have to be as descriptive in your homework, but I wanted you to know why we're putting it that way. So now it's just a matter of substituting in these pieces for A, B, and BC. So we have x plus 9 and 4x. And so we go ahead and substitute. Now we're just doing an algebra problem. And both sides we subtracted this x from both sides, and I end up with just 9 equals 4x minus 1x is 3x. And again, I'm assuming that, you know, Algebra 1 went okay for you last year. If you're needing some Algebra 1 help, you need to let me know, because this isn't going away. It's going to be around all year. So that is okay. I know last year didn't end well for everyone, and so we might need a little refresher, but I don't want you to get stuck up on that. All right, just got to let me know, and we can always meet and set up a Zoom meeting or something like that. So now I have 9 equals 3x. I'm going to divide both sides by 3, and I end up with x equals 3. Now I'm not done there though, right? The question said solve for x, okay? And actually the very first problem in the exit ticket for this section is a problem just like that. Solve for x, and then it gives you a length of one of the segments it wants. Okay, well in this case it wants all 3 of the lengths of these segments. So if you stop at x equals 3, you're not going to be done with the problem. So we have to plug in now x everywhere we had it up here. So we see that we've got it, let's see, I'm going to change my highlighter. We've got AB equals x plus 9. And so we're plugging in 3 plus 9 instead, since we got 3 for x, and we end up with 12. Okay, if I plug in now for BC is 4x, so 4 times 3, that's kind of hard to see now, isn't it? 4 times 3 gives us 12. Well, if you look up above, that's kind of our check. We know that A, B, and BC are supposed to be the same length. And so if I would have plugged in a number and gotten 12 and let's say 15, I would have to tell myself, okay, something went wrong and I didn't get the right value for x. And then segment addition postulate says, okay, well I got these 2 pieces of the segment, and added together they're going to give you the whole thing, AC. So AC is both the length of AB plus the length of BC, so we get 12 plus 12, and I get 24. Okay, so I'm going to actually pause here, and I want you to take some time to work out the next problem on your own, and then we'll come back together and you can check your answer. So pause here. Alright, now that we're back, you should have ended up with x equals 5.5. When you plug that back in, you get AB and BC both equaling 10, and then the length of AC equaling 20. So I'm going to ask that you go ahead and pause, and then if you need more time to copy this down,